Well, off and on I've been trying to get my CNC lathe running, and it was kind of running at one point there, and then it got kind of glitchy, and then I thought I had it fixed, and I posted the video of the arc I turned on the end of the aluminum. Well, then the next day I came out, fired it up, and the glitch is that the Z-axis was only moving to the left, okay, which I believe is the negative direction. And no matter whether I did, you know, a G-code input in here and told it, you know, to go right or left, or I did the jog buttons right or left. And I've been fighting with this and fighting with it, and doing all kinds of different changes and all that kind of stuff, trying to figure out how to get it to do that. Now, I could, this is the controller box I have, okay, came with the lathe. You know, I basically bought it all set up like this. It's not quite finished. It was finished enough to use, you know, but it needs some guards and stuff like that over the ball screws and stuff. But anyway, these are the two cables, and one has X and Y, and the other one has Z and A, and they just plug into the back there. Now, if I swapped these, okay, the problem would move, and since it was a whole lot easier to grab this with power off and back it back out when it went too far in the one direction constantly, I just changed those plugs over, and the problem moved. So every time I would jog it, it would just keep going the same direction, which eventually just pushed it all the way to the end and bound it up against the physical limits. So so with some help from Doorknob, this is screen name on cnczone.com. He was talking about back probing the pins from the thing and from the computer on the parallel port there, and you know, I was hung up with the idea that the board was bad, because you know, why would the computer be bad? I should know a whole lot more about computers and parallel ports and all that kind of stuff, but I don't. I've been in electronics for a long time, and I haven't enjoyed it for a long time, and so I just don't deal with it, so I'm pretty rusty and stuff like that. But anyway, so what I did for troubleshooting here is I took what he said, okay. Now I arced off the tip there. I haven't sharpened it back down. I probably should, but I just got a piece of welding wire wrapped around here making contact so I can back probe, and I ended up having to sharpen it to a point so I could get in there. So I've got the, let's see, oh, let's try not to jerk it around too much here. So set up in Mach 3. This is a Hobbycnc board. It's the 4AU PC revision number 2. The pinouts are set up so that the direction change is on pin 2 for the x-axis, and it's on pin 6 for the z-axis. Okay, so what I did was I came in here and it's hard to see this, back probe pin 2, and with the computer on, let's see if I can get in there. Okay, there we go, I'm on it, I think. Let's see here. Yeah, see that? Okay, so that reads 5 volts, and then it goes down to below 1 volt. I mean, that's like 10 millivolts. That's nothing. Okay, that's what it should read. Now, when I was originally, I had the parallel cable plugged into the existing parallel port on the computer. Okay, and I checked 2, and it would drop from, it would switch between 1.5 volts and 4.5. Okay, and that axis always worked. So that was enough change for the board to recognize the direction change. Enough voltage drop, change back and forth. The z-axis, okay, let's see if I've got it connected. Yeah, it's connected to. Okay, on the existing parallel board, off the motherboard or whatever, it was only changing from like 3 to 4.5. And so every now and then the axis would jog correctly, but then it would get stuck. And so I was like, man, you know, and so I kept thinking it was the board. But once I finally, I was just about ready to order new chips too. Newark.com has the chips, but anyway, the voltage reading I was getting on there, I was finally like, oh, duh, that's the 5 volts coming out of the computer. Okay, so what I did was I actually had a PCI parallel card. Okay, and so I went ahead and changed out the PCI parallel card, and I was gonna go back and change all this and show all the changes in Mach 3 and stuff like that, but I thought, you know, I just want to point somebody in the right direction, kind of thing, if they have a similar problem. I've got the controller off right now. If you'll notice too, I left the parallel cable plugged into the board here so that I can easily plug into the ground here. This is the power supply ground here on the board, and it's common to the grounds for the parallel port. If I unplugged it and you know, I could plug it into like 18 through 25. I think any one of those should be a ground. Don't quote me on that for sure, but so I've got the controller off, and you know, when you're working in something that's set up like this, watch out for those capacitors. Those will carry some juice there. That'll make some sparks. So let's see if it's working right still. Okay, so what we're looking for is just going to kick it on there. So that's going back and forth like it should be, and this is the one that was always bad, and so there we go. You should be able to see that now. Let me slide this over just a bit here. This is going to have to I'm going to have to figure out something here to do this. Watch. Look at all that flex. That's all backlash. So that's got to be taken care of. So I'm going to have to do some work on it. Just not today or tonight. So I'm just tickled pink to have it correct. Now in Mach, I also had to go back and change the configuration, okay, because the new board had a different address. And originally I was going to go through and do the video and show all this. It's under configuration, ports and pins. You got to change this port address here. So you can go into your control panel, and the reason I decided not to necessarily show all of this is the fact that this is a old Windows 2000 or whatever, and a lot of guys aren't using anything that old. But under system, hardware, device manager, it's like a 400 megahertz machine, so it's pretty slow. Ports, so I changed the existing printer port to 2, and then that way my PCI card I changed to port 1. I don't know that it wouldn't have priority. I just wanted to make sure that it did have priority. I also went into the port settings here. That's where I changed it to LP2. And then the resources, it had the 03F8, I believe, address. I changed that. And basically, you do that, you just click on that and do change settings. Cannot try choosing. You have to go down here, and I found a different one that popped up and selected it. So anyway, I got those changed just to make sure that it didn't try to go to the onboard parallel port. and then you double click on this one, and then I'm not sure if that needs to be that way or not, but I changed it to pt1. And then this is where you get your address, DCF8. Write that down, and then go back into Mach 3 and type that in here. Now I just clicked in there and backed it up, and then you got to click apply. If you hit enter, I think it exits the screen without doing anything. And then motor outputs, this is where there's the x-axis. That's how I found out that the direction pin was pin 2. It seems to be backwards with the Hobby CNC board compared to some of the other boards I've been researching and stuff. And there's the z-axis, so that's how, right there, pin 6 is the pin for, what do you call it? The direction pin for the z-axis. So there really isn't anything else in there that I had to mess with. I still need to go through and do a little motor tuning. And every time you back out, you'll have to reset it there. So okay, so I gotta go back in here real quick because while I was messing with it earlier, I changed this on the direction pin, and so now my buttons were backwards. So let's see if they're correct now. Yep. All right. See what it's doing there? I was stalling. I gotta go in and play with the motor tuning or the or the stepping or whatever. I changed the stepping to quarter steps on the board, so I think I may go back to 1/16 and see how that works. So anyway, that was the ordeal with the troubleshooting here, and thanks again to Doorknob. Well, if you look right down there, it's printed on the circuit board how to set up the jumpers for the steps. Okay, so my understanding, I'm new to all this CNC stuff, so from what I've been reading, it seems like the more micro steps you put it in, the slower it's going to go. Now, this is a very small machine, so I don't need really high feed rates. It'd be nice to have high rapids to move back and forth, but it's not going to be traveling that far because I'm not working on very big pieces or anything. So the micro stepping, once you get below a quarter, evidently they said that it doesn't affect the accuracy. So maybe somebody can chime in and say exactly why it would be better to go to 16th over quarter or whatever. But let's see if I'm reading this right. It says 1/16 step, J2 on, J3 on. Okay, and the asynchronous and the synchronous on J1, I'm not exactly sure which way that needs to be. But when I got the machine, the other guy who knew more than I did, or do for sure, he had all the jumpers on, and that's the wrong axis. Well, alright, there's that one. Okay, that one's on. Let's slap them back on the x-axis. All right, close enough for that. See how much less it moves? I haven't changed anything. So it was on quarter step, so it's going to be moving basically a quarter of what it was. So I'll put the shift key down. No more stalling, nice and So now I can go back into motor tuning and change that a little bit. And let's see if we can get a bit more speed in there. I slowed it way down at one point. So the steps, I need to change that. Let's pick the x-axis. Let's change the steps back to 45714. 45714. That's the number of steps, because I've got a 40 tooth and a 14 tooth gears on the stepper motor, driving a 5 tooth per inch ball screw. Okay, so that gives me an effective turns per inch or whatever it is on the motor. So it's got to go 14.28 to get to 1 turn. The 3200 takes 200 steps, full steps on that stepper motor to make 1 revolution. Well, if it's in 1/16 micro, then it's going to take 3200 steps. Hopefully all that's coming through. It's going to take 3200 steps to show up. So basically I take the 14.28, and I hope I'm doing all this right. Somebody correct me if I'm not, for sure, because I don't want to mislead anybody else. But so to get 1 inch, I times that by the 3200, and that gives me the 45,714. That's how many steps it takes to move that the carriage 1 inch. Okay, and it's the same ball screws and motors and everything. Oh, you know, it just dawned on me. That's my z-axis. My x-axis, I'll have to look. I don't know if it has the same pulleys in there. I've just been assuming. So, okay, well, I don't have to change it right now for what I'm playing with, and it made that arc on that aluminum piece really nice. So, it must be pretty close. So let's see here. Let's move the acceleration up. We'll put it about halfway. Let's save the axis setting. We've got to back out here. Now, so that's still moving pretty smooth there. And there may be a better way to do this. I don't know. Let's get a little crazy here and run them both up and see what happens. And it gives you numbers down here, so you can actually get them close. But both axes are going to be different. Big change there, huh? And that's pretty good. So this controller is running at 31, 32 volts, somewhere around there, and 2.5 amps. So apparently this system likes it. We'll max them both out there and see what happens. I don't know that it'll be able to stay there. I think there's a big difference between running it on jog and running it on a program. So if it stalls out there, I'll have to go back and do it again. So let's see what we can get with the z-axis. Well, the acceleration's already up there. The steps are the same there. So z-axis. Let's see what happens with the velocity all the way up on that one. Oh, shift key. Alright, and I'll have to look that up some more. What the heck is the G0 X1 maybe? Let's zero these two out. I'm in a fairly safe spot there. My understanding is you can put the spaces in, you don't have to. Nice, huh? And then you can hit the up arrow, get it again. But it didn't move. Not sure why it didn't move. Let's type another one. G0x negative 1. So that has to move back the one I went and another one. Okay, it's not telling it just to move -1 inch. It's telling it to go back to the -1 position. So since I had it zeroed, it moved one this way, and then it had to go back two. So let's see if the Y, or the Z rather. So G0Z1 should go to the right. Okay, and as I tune this thing and get it figured out and stuff like that, I'm gonna have to go in and check it with the dial indicator and make sure that when I tell it to go 1 inch, it actually goes 1 inch. So then G0Z -1. And it's going smooth and there's no stalling or anything like that. So for now, I'm going to leave that tuning the way it is. That hiss is normal. If you get a board, one of the new Hobby CNC Pro boards that have a, it reduces the current and idle. When it's sitting here like this, it won't be as loud because it won't be putting as much current in there to hold it. So, because these are being held right now. And so if you do that while you're working on the machine, you've just lost steps because you've changed. See, the DROs don't change or anything. So the machine still thinks it's in the same position, but you've moved it. So, okay, let's set up a little piece and see if we can get it to run.